Imagine you are standing at the base of a structure that reaches so high its summit is obscured by the clouds. It is hundreds of thousands of tons of steel, glass, and concrete, standing perfectly still against hurricane-force winds and the relentless pull of gravity. A skyscraper is not just a tall building. It is a vertical city. A masterpiece of defiance that forces us to rethink the very limits of what is possible. But to understand how we build up, we first have to understand how we go down. The birth of every skyscraper begins in the dark. Before a single floor can rise, engineers must reach the bedrock. If you tried to build a massive tower on topsoil, it would lean, sink, or collapse under its own weight. Crews dig massive trenches to create slurry walls, reinforced concrete perimeters that keep the surrounding earth and water out. Then, they sink caissons, or piles, enormous steel and concrete pillars, hundreds of feet into the ground until they find a solid foundation. The taller the building, the more it relies on this invisible anchor. Once the foundation is set, the core begins to rise. Think of the core as the spine of the building. It's usually a massive, central cylinder of reinforced concrete that houses the elevators, stairs, and utilities. In modern construction, we use slip forming, a process where a specialized mold moves slowly upward, pouring concrete continuously. The core is the strongest part of the building, designed to handle the compression, the massive downward force of the building's weight. Surrounding this spine is the skeleton. In the early days of skyscrapers, we used heavy masonry, but today we use high-strength steel. This steel frame handles the tension, the forces that try to pull or twist the building. The speed at which these steel beams are hoisted and bolted together is the heartbeat of the site. It is a dangerous, high-altitude dance coordinated by massive tower cranes that actually grow with the building, jacking themselves up floor by floor as they climb toward the sky. But as you get higher, you encounter a new enemy: the wind. At 800 or 1,000 feet, the wind doesn't just blow. It pushes with the power of a locomotive to keep the building from swaying so much that the occupants get seasick. Engineers use a tuned mass damper. This is a massive weight, often a steel or concrete ball weighing hundreds of tons, suspended near the top of the tower. When the wind pushes the building to the right, the computer-controlled damper moves to the left, acting as a giant counterweight that cancels out the vibration. Then comes the curtain wall. This is the glass skin that gives the skyscraper its soul. These aren't just windows. They are highly engineered panels designed to withstand extreme wind pressure and thermal expansion. Because glass expands in the heat and shrinks in the cold, the skin of a skyscraper is actually floating on the frame, held by brackets that allow it to move slightly without shattering. These panels are often coated with specialized films to reflect solar heat, keeping the interior cool without crushing the building's massive air conditioning systems. Inside, the challenge is logistics. How do you move thousands of people to the 100th floor in seconds? The answer is the double-deck elevator and sky lobbies. Instead of one elevator going from the bottom to the top, you take a high-speed shuttle to a midway point, then transfer to a local elevator. Without this innovation, the core of a skyscraper would have to be so full of elevator shafts that there would be no room left for offices or apartments. Fire safety is the ultimate priority in a vertical environment. Because fire trucks can't reach the top floors, the building has to be its own fire department. Every floor is a sealed compartment designed to contain a fire for hours. High-pressure water pumps and massive storage tanks are strategically placed throughout the heights. And refuge floors, reinforced, smoke-proof areas, provide a safe place for people to wait if evacuation isn't possible. Building a skyscraper is a race against the elements, the budget, and the clock. It is a 24-hour operation involving thousands of workers. From the iron workers, who walk the narrow beams in the sky, to the glaziers, who hang the glass over the abyss. It is a logistical miracle where every bolt, every bucket of concrete, and every pane of glass has to arrive at the exact second it's needed. Often on a crowded city street with no room to spare. Why do we do it? Why do we spend billions to stack rooms on top of each other? It's partly about space in crowded cities. But it's mostly about the human spirit. A skyscraper is a monument to our ambition. It is a statement that says we can conquer the wind. We can stabilize the earth. And we can touch the sky. The next time you see a crane silhouetted against the sunset atop a rising tower, don't just see a construction site. See a battle of physics. See a triumph of coordination. See the newest chapter in a story that began with the pyramids and is currently reaching for the stars. As you look up at these glass giants, do you see them as cold monuments, a corporate